This will be just a guide for those of you that have not been able to be to class the last couple of times. So a guide of the notes that we went through, those two classes, and just a little bit about each. I'm not going to teach them in this video. This will be a guide. The notes should do it. I mean, the recursion's tough, but the notes cover it. Okay, so, and we just got to move on. So the first day that I was back, we looked at everything that we had not yet done one way or another with topic 1. I mean, a bunch of it we did in class, a bunch of it you did yourselves over the winter break, other stuff you would have done with your IA, with Mr. Ram, and so on and so on. So the things that we had not covered, which I covered there a class or two classes ago, are these three. And if you looked at the homework, you'll know what they were, but you may not have done the homework by now. So here we go. Evaluate alternative installation processes. Basically, there are 4 ways you can implement or install a full system. So the only thing that I'll put into context with this video is that all of topic 1, as you should have figured out by now, is not about the micro, it's about the macro. It's about big systems. It's about a whole banking system. It's about a whole school's content management system. We're not talking about one program. We're not talking about one piece of hardware. We're talking about lots of software and lots of hardware all together. And so the question is, if you're implementing a new, what did I use as the examples in class? I used the mask checking AI systems that were installed last year at our school, and I also used, I think, the idea of going from haiku to Google Classroom. So implementing a new AI mask checking system or Google Classroom or any myriad of other big systems, you can go about it different ways. And so that's what this is about. Parallel running, what a pilot program is all about, what the direct changeover method has as advantages and disadvantages, and what it is, and phase conversion. And then there was a second of these 3, which kind of relates in terms of what are the problems that may arise as part of data migration. So again, just in a few minutes for this video, a big thing to point out here is we're talking data migration. We're talking something that's big. We're not talking about one file going to another computer. We're talking about installing a new system in a worldwide bank, for example, or just in a really big school like ours. There's a lot of data that's got to be migrated. It's got to go from the old system to the new system. And there are lots of issues that can come up. Basically, it boils down to, as you look through these notes and answer the questions, it boils down to losing data or losing part of the data or corrupting the data, making it not what it was, or just having trouble with incompatible formats. And I think it starts with incompatible formats, file formats, docked pages, for example, file structures where in a database they're just not kept the same way in the old database and the new database, and somehow you got to figure out how to translate them. Incompatible validation rules. You'll not have done checksums and parity checking, but read through this and I think you'll get the idea. And then what we're so familiar with is international people, different formats of currencies and dates and so on and so on. Okay, and then I guess the second part here that I talk about: incomplete data transfer, corruption of data, and complete loss of data. All things which are major issues which need to be handled with data migration. And a third of the top 3, a big one, but again, it's here in the notes, and this has not been a perfect year by any means. So fortunately, you've got good notes, and if you've got time, take a look through. Testing is absolutely crucial. Testing is arguably the biggest thing that's done in an IT company, other than, just thinking on the spot here, that first initial light bulb at the dinner table where you write down on the back of a napkin an idea. The testing to make sure that systems work. There's no use using systems unless they work. So many systems, so many IT systems, it's life or death, whether in hospitals or, electrical grids. If the electrical grid goes out across a city, it's a problem. So anyway, all sorts of different kinds of testing. This notes page I'm not that happy with, but I'm going to leave it. You just need to distinguish between the testing, which is talking about debugging and things that you would be testing in a micro level with one program, and the rest is talking about more system, or the whole kit and caboodle you're testing. So just again a kind of a walk through, a stroll through, an introduction to the notes. They start with more micro, more when you're doing your program, you are going to test normal, abnormal, border, extreme, and wrong type data for each of your inputs, right? So this is the sort of stuff that you can do as one person with one program. And then this is the only place that it really fit in the whole curriculum. So here's where we talk about the different kinds of errors that you can debug. Syntax errors, errors of spelling, semantics errors, errors in intent, no spelling mistakes, no punctuation problems, but you just didn't do the right steps. And runtime errors, which I talked a little bit about in class. And if you weren't there, don't worry too much about it because it's not a big part of the course. Runtime errors are just the errors that you get as a programmer, hopefully as a programmer before it's released to the public, where in the process of running, something happens that was not handled correctly, or was handled correctly, like dividing by 0. And then on a more macro level, A/B testing. One group uses the system one way, another group uses it the other way. Which group is happier, basically? User acceptance testing is the type of testing that you hopefully are in the process of doing with your client. It's so this is before beta release. This is where you bring in the users, or you go to the users and with your system, you say, okay, try it out, what do you think? I'm giving benefits and drawbacks to each of these. Beta testing is where you've got a version of the software or the system that you're pretty happy with. You don't know exactly how it's going to work in the real world, so you send it out to those that are willing to take the chance on it not being the final product. They want to get an early start to trying this new software, so they are part of your beta testing group. And then I give a specific example of testing a system. And so those were those 3 that were not covered any other time. And there are a bunch more here, but that's it for topic 1. And of course 2 and 3 and 4 are all done, and 5's pretty much done, and we're left with a case study and you're working on your IA. But anyway, so these, there were actually 2 that I said we'll come back to if we have time, or in the context of doing a review is probably the way to do that. And the reason that I'm not taking the time now with all these other things to do is that I've found over the years that at good international schools like ISB, kids do a really good job with talking about social and ethical issues associated with anything, including the introduction of new IT systems. Though, again, there's a little bit more to it when you're talking about IT systems. The big thing is the stakeholders. Are the stakeholders happy, or are they not happy? Socially and ethically, have you done anything like privacy invasion that you shouldn't have done? So you can take a look at that at some point before you may exam. But like I say, I just have generally found that kids do well. They've got lots to say on these things, and that's great. It speaks highly of international schools in general. And this one here is more, it's talking about robots, basically. It's talking about the moral, ethical, social, and economic environmental implications of the interaction between humans and machines. Well, okay, not just robots, but robots is a big one to be thinking about now in terms of all these issues, and you tend to do a pretty good job with that. So the others that we just peripherally did in that class of a couple of classes ago, again, just trying to get this stuff done any which way we can, and this is pretty straightforward stuff, and I'll probably come back to it again anyway. The idea of human interaction with systems, the ideas of usability and accessibility. And I actually, in the practice exam, asked a couple of questions that, or at least one, that were about this or was about this. So with usability, we're talking about different kinds of devices, and we're talking about how easy they are to use. And the way, like I left it with the students that were there, is I've divided up usability into 4 plus 2. Learnability, efficiency, errors, both lack of them and when they happen, how they're handled. Satisfaction, do you like your iPhone? You probably do. Accessibility, and then the 2 extra ones that are mentioned in the teaching note, which are newer maybe to you. By accessibility, we mean that everybody, whether they've got hands or eyes that function or hearing that functions or whatever, but everybody has access to the systems which you are designing. That's what accessibility is about. It's about people, it's about helping people who have disabilities of one sort or another. And ergonomics is all about having the machinery, the systems, the software that you design, not hurt the people who are using them. That they are designed with human form in mind, and so you get your ergonomic keyboards and your ergonomic chairs and your ergonomic mice and so on and so on and so on and so on. So I guess the best thing to do is just go back, and that's what these are about. And just keep in mind that accessibility is a subcategory of usability. Usability has those other, if you like using it, is it ergonomic? But accessibility is one of them, and accessibility is so important that it's a separate assessment statement. And like I mentioned in class, all you've got to do is go to, what's it called now? Accessibility? Yeah, it's called accessibility now. And the Mac operating system, it's got all sorts of stuff for people with different dexterity or vision or hearing, etc. Issues. And nobody does a better job, like I said in class, than Apple at addressing all of them. So that's your one class. I took about 10 minutes to go through it, but anyway, there you go. And then the other class that a bunch of you missed was on recursion. And the recursion notes are good. And we did go over recursion at least twice before, and once in 10 minutes, like the very first teaching note says, and then another time in a little bit more detail with code. But this was a class where I actually went through these and didn't quite get done. Got 1 or 2 more to go through, but there's a lot of stuff here, and if you missed class, you missed class, and nobody knows better this year that there are things going on that you got to miss class than me. So do your best at going through these, and the best thing to do is to go through them in order. We didn't get down to 5.1.16. But the thing to do, for those of you that missed the class, and for those of you who may be watching this video just by way of review, is that I have combined both D, the object-oriented programming option that we're not doing and nobody's doing in 2022, neither in 2021, right? It's the option that was dropped. But the problem is, a lot of the best stuff about recursion was from the D. And so this is the way that I arranged the notes a number of years ago, and it's the only way to do it. If I don't know how people that would just do the 5 would be able to do some of this other stuff. So do your best to go through this. This is the big one. This is the one that there's just a lot of stuff there. But define recursion, I'm just going to, I'll click on them. Here we go. Define recursion, method calling other instances of itself. It's just a definition. 5.1.1, identify situations that require the use of recursive thinking. Basically, I'm saying there are 3 situations. I won't even read them, but here they are. Point 2 is identify recursive thinking in a specified problem. That's where you're saying, aha, here it is, recursion. Why is this recursion? Because a method is called, in fact, twice within itself. But really, it's other instances. One of these 2 other instances will be created each step through the recursive binary search. Or the factorial. Here's the name of the method, factorial. Within the braces of the method is factorial. Aha, recursion. And then the big one, D.4.2. Well, it's just good stuff, but you need a base case, otherwise recursion will go on forever, so that's a good section on that. The fact that all these things accomplish iteration, but recursion sometimes is the only way to do it. And so we're back to this, why do we use it? This copy and paste one I just showed you, but basically the main reason is that there's no other way possible. But this is also good in that it goes into why not to use recursion. It's a memory hog. And this is the one that has an explanation of a couple of classic, and this we'll get back to next time, because this is the one that we didn't do. So this is the big one on recursion. You will have questions in May on recursion, and you will have them on your mock exam, and it's good stuff. It's really interesting, so take the time to go through. What's this? This is the one to pass on in 2021, by 2021, I mean 2022, so skip this one. And then this is where you'll have to watch the video. We did do this, but you probably have forgotten. So that's the way that tracing recursive algorithms should proceed. You keep track of each call, and then they ultimately resolve and pop off the stack, go and finish business. But that's all explained here in recursive tracing, and there are lots of exercises, of which a couple of them are asked from the homework. And then, like I say, this is the one that we'll get to. Well, if you're still absent, let me talk a little bit about it. That one of the issues of the binary tree is great in that it is dynamic, right? And it's great in that it's efficient. But what it's not necessarily efficient for is visiting each node because of the way it's structured. How do you do it? If you have an array, you just straightforwardly go through it and you read. If you want to traverse a list, fair enough, each node has a link to the next node, so you just follow the links. But a tree, how are you supposed to do it? You're supposed to go this way, and then that way, and then how do you do it? Well, there's a recursive solution. And what we're going to do next class is talk about how these recursive calls, do I have the code here? Yeah, let me just go back to the code, which would have been here. And even the kids that have been there past couple of days haven't seen this yet, but this is the code, right? You're going to have this traverse in order, or traverse post order, or traverse pre-order to go through all the different nodes of a tree, of a binary tree. And so basically what you're going to do is, as long as you're not at the end of a leaf, then you're going to traverse left, and then you're going to deal with the node that you're at, and then you're going to traverse right. You do that for every leaf that you get to. Every leaf that you get to, every next leaf that you get to is going to look to its left and its right and deal with the value that it has in between. So that's the code for in order. So as we're going to do next class, you're going to see that there are these three different ways. One of them is, what was that? That was in order, I think we're looking at. So there's pre and there's post. And the idea with these three orders is you either, like when you're up here, you either deal with M, like print it out first, that's pre. Or you deal with it and print it out last, that's post. Or you print it out or deal with it in order, where you get to the smallest one first, basically. So in order is going to be go to the left, 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 and then deal with the left. And then deal with it, and then deal with the right. So there's a lot to this, but basically read through it, deal with the node, left and right is pre, deal with the left, then deal with the node, then deal with the right is in order, which will give you alphabetical or numeric order as you traverse and print out, for example, and post order, deal with the left, deal with the right, and then deal with the node. And so I went through, played this lovely video, which you really should take a look at. And watch it a couple times and you'll get what's going on, and maybe you'll get how it's working. But I mean, the reason that it's here is that there is recursion going on. Every time we get to a new leaf, a new node, not new leaf, a new node, we recurse left and we recurse right, we repeat. And then, which we'll do next class in case you're still not there, the idea of the pre-traversal, how it actually makes sense and works, and in order and post order. And that ended up being a lot longer than I thought.